All right. Okay, so we're still talking about trig functions, guys. So here's the thing. The last things we were talking about trigs at all these angles, okay? But notice, they're very specific. 30s, 60s, 90s, 45s, right? So um, the problem is, so far, is I'm missing a bunch of angles. Do you understand that, right? Because how many angles are in a circle? 360, and I'm only dealing with about 20 of them, right? So there's a whole bunch of angles that I'm not taking into account. So the thing is, does that mean I can't do trig at those angles? And the answer, of course, is no. You can do a trig at any angle. It's just those were the nice ones. Those were the nice, and everything was set up real good. So I have here some rules that we're going to follow for trig function at any angle. So of course, let theta be the angle in center position with any xy. So imagine again, you're still on your coordinate, and I can give you any point. Okay? Does everybody realize that at any point, like say I give you a point over here, I can create an angle, and of course, thinking about it in a circle, there would be a radius, right? So I'm going to call that r. So to find the trig function at any angle, any point really, I have these formulas, okay? So it's sine theta is y over r, cosine theta is x over r, tangent theta, as we already know, is y over x, cosecant is r over y, secant is r over x, and cotangent is x over y, okay? The only thing I need to find now is my r, my radius, and that has a formula too. It's the square root of x squared plus y squared. And remember, that radius can't be 0, because you have to have a length of something. So I'm going to give you a couple seconds to copy that down, and then we'll move on. Alright, so these hopefully look a little familiar. So sine is the y still, cosine still the x, but they're over r. And what do you think r stands for, by the way? Radius. Because remember, if I can make a circle out of this. And I have a formula for r. It's square root of x squared plus y squared. Does this kind of look familiar? I'm sorry. Does this formula look familiar? What does it look like? Say that again? A quadratic. So I have a squared, an x squared, and a y squared. I'm taking a square root. It's just Pythagorean theorem. It's just a basic. So think about it this. If I'm trying to find this, does everybody see that there actually is a right triangle there? Okay, so that's what I'm using. It's just a derivative of the Pythagorean theorem, okay? It's just without all the fuss and muss. It's already done for you. So all you need are these things. And remember, so notice, same thing, cosecant still the reciprocal of sine, secant still the reciprocal of cosine, cotangent still the reciprocal of tangent. All right, so very simple. Here's your problem. So it says let negative 3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. Okay? So, here's the situation, people. Where is negative 3, 4, by the way? So it's over here in the second quadrant. So negative 3 to the left, 1, 2, 3, and 4 up, 1, 2, 3, 4. So here's my point. I'm coming here. Does everybody see the angle that I've created? Right? I'm going to call that, of course, theta. So there's my angle that I created. Okay? So, based on this information, can you tell me, of course, what my x is? Negative 3. What's my y? 4. And then what's my r? How do I find my r, guys? What's the formula? Square root of x squared plus y squared. Do I have what I need? Yeah. So this is going to become the square root of negative 3 squared plus 4 squared. Be very careful. Do you see how I wrote it? Why did I put a parenthesis around that one and not the other one? Because it's negative. If you're going to do this in the calculator, which is totally fine, it has to have parentheses around because of the negative. If you do not put that negative, what's going to happen is you're going to get a wrong answer. Calculator is just going to do exactly what you tell it to do, so be very careful with that, okay? I don't need a calculator for this one because I know negative 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and what is the square root of 25? So I know my r in this case is actually 5. So guys, if I know x, y, and r, I can essentially find everything. Okay? According to your rules, sine of theta was y over r, correct? So in our case, it'll be what? 4 over 5. Is that simple? Cosine, according to your rules, is x over r, which in our case would be negative 3 over 5. And according to your rules, tangent is y over x, so in our case would be negative 4 over 3. That's simple. So it's, remember, if one of them's negative, the whole thing is negative. Okay? So you don't have to put a negative just on the top or just on the bottom, just put it up front. Okay? That's simple. Does everybody see how this is going to work? All you need to know is your x, your y, and of course your r, and you can essentially find all 6 trig functions if you needed to. Any questions on this one? Pretty simple, right? We good? So, if I move my point, does anything change? No. Okay? Nothing's going to change. As long as your point's on the x and y axis, you can do this for everything. All right. Okay? So, here we go. New point. New point. Now I'm going to give you the point 4, 3. 4, 3. So if I give you the point 4, 3, again, I want you to find the sine, cosine, and tangent of theta. Find the sine, cosine, tangent of theta. So, break it down. What's my x? What's my y? What's my r? So, it's going to be the exact same. Does everybody see that? Because it's 4 squared plus 3 squared, which is, again, 16 plus 9, which is, again, 25, which is, again, 5. So your r, in this case, is still going to be 5. So are my answers going to be the exact same then as the other one? No. Why? Because my x's and y's are different. Okay? The r may be the same, but the x's and y's are different. So sine was y over r, which in this case will be 3 over 5. Cosine, which is x over r, which is 4 over 5. And tangent, which is y over x, which is 3 over 4. Where do you think this will get difficult? I can put, remember these, I can put any number, anything, right? So I'm going to start putting radicals, but again, you know how to fix that, right? So that's the only difference that'll come up. Yes, you can never have a radical in the bottom. However, so guys, remember, what if it's a large radical, like what we had in the warm-up, 160? I need you to simplify, okay? So you learned that week 1. So remember, when you got to reduce the radical. So split it up into 2 numbers and make it look smaller. All right? Let's try one more. Let's try one more. So here's your point. Your point is 8, negative 15. 8, negative 15. So what's my x? 8. What's my y? What's my r? Well, how do I find my r, rather? Square root of 8 squared plus negative 15 squared. So, remember that negative 15 has to go in parentheses. Okay? So, we can skip a step here. Can you just tell me what 8 squared plus negative 15 squared is? Add them together. So what's 64 plus? Now, Brian, remember, it's not negative 225 because it's a negative 15 times a negative 15. So a negative times a negative is always going to be positive. So, guys, anytime you here's my hint. Anytime you square anything, it's always going to be a positive answer. All the time, okay? So never get a negative here. So 64 plus 225 is what? 289? Oh, so this one's nice because the square root of 289 is what? 17. It's a nice whole number for me, so I don't have to worry about reducing it. Okay? So my r is 17. So then, guys, tell me, what's my sign? Remember, it's y over r, so it would be negative 15 over 17. My cosine is x over r, so it's 8 over 17. And finally, my tangent is what? Y over x, so it would be negative 15 over 8. So all you have to know are those formulas that you got in the first page. Okay? Which ones? You got them. They're right there. Okay? Any questions? We're good? Alright. So, let's try something else. This is kind of like the warm-up. So if I gave you the fact that tangent theta is negative 5 over 4, and the cosine of theta is greater than 0, I want you to find secant, sine, and secant. Okay? So, in the blue letters, that's all the problem says. Given that tangent is negative 5 over 4, and cosine theta is greater than 0, what does that even mean? What does cosine theta greater than 0 mean? It's what? Somebody said it. It's positive. So does everybody see that this literally means that cosine is positive? More specifically, cosine represents which one, x or y? X. So what they're really telling me is x is positive. Does that make sense? Okay? Why would they tell me something like that? Because here's what happened. Does everybody agree that tangent is y over x, correct? Tangent is y over x. Now, I told you that tangent was negative 5 over 4. So, does everybody see I'm telling you that y is what? So here's the thing. It's negative, so one of them is negative, right? Which one? So, cosine is your x, they're telling you the x is the what? The positive one. So guess what? The y has to be negative. Does that make sense? Do you understand what I'm telling you there? So I told you at the beginning that cosine was positive, therefore x is positive, right? And tangent is y over x, so that means that the bottom is the positive one. Therefore, the y is the negative one. You see what I'm saying? Okay? So I'm literally telling you that x is 4 and y is negative 5. Right? So if I need to find sine and secant, what's the other thing I need? I still need r. Okay? And how do I find r? Square root of 4 squared plus negative 5 squared. So help me out. What's 4 squared plus negative 5 squared? 16 and 25, which is? You have calculators. You don't have to guess. 41? So r is the square root of 41. And square root of 41, is that a whole number? No, it's not. So then what do you think? Can I reduce it maybe? No. How do you know you can't reduce, by the way? It's a prime number. You guys know what prime numbers are? Should have learned about them a long time ago. And the only reason they're helpful is for stuff like this. Because if I wanted you to reduce it, you have to break it down, correct? But prime numbers are what? They're not factorable. Their only factors are what? 1 in itself. So 41 is one of those numbers where like 1 in itself. Give me another example of a prime number. 13, 3, 7. You guys understand, right? So if it's those numbers, don't even try. Okay? So my r is going to stay square root of 41. So the question was this. What's sine and what's secant? So by definition, sine is y over r. So in our case, negative 5 over square root of 41. Is there a problem with that? So then what do? Negative 5 square root of 41 over 41. And then, of course, can I reduce that? Nope. So that's my final answer. And then finally, secant, by definition, is what? R over x. So in our case, square root of 41 over 4. Does everybody understand where I'm getting these y's and x's from, right? From the tangent, the fact that tangent was that. And is there a problem with this one? Nope. It's fine. Square root of 41 over 4 is perfectly acceptable. Any questions? So, you see how in this case, like, okay, the first ones were easy, right? It's like, well, here's x, here's y, blah, blah, blah. Just do everything. But in this is how you'll mostly get the questions. Like, I'm going to make you think about how to get x and y. I'm giving you enough information to do it, but you have to use those brains of yours to figure out the rest. Any questions? Okay, I would like for you to try this one on your own. Try this one on your own. Alright, so this question says this. Given that tangent theta is negative 15 over 8, and then it says sine theta is less than 0. Guys, what are they trying to tell you here? Good. They're saying here that y is negative. Does everybody understand that? That y is negative. Now, tangent is y over x. Does everybody agree with that? Tangent is y over x. And so in our case, it's a negative 15 over 8. So where does the negative go? To the y or to the x? So in our case, it'll be a negative 15 over 8. Does everybody agree with that? Now, of course, all I need now is my r. So the way I do that, square root of, or I mean, does it matter, by the way? No, so you're adding, so it doesn't matter. So negative 15 squared plus 8 squared is what? Yeah, so what is that? 289? And then again, worked out very nicely for us. R is the square root of 289, which is 17. Okay, so R is the square root of 289, which is 17. So then finally, if I want sine and secant, by definition, sine is what? Y over R. So in our case, negative 15 over 17. And then finally, if I want secant, it's r over x. So in our case, try that again. 17 over 8. See how easy this is? Okay? You just got to be paying attention to what they're telling you and what they're giving you. Again, what if I mix this up, people, and I told you, what if it was just negative 15? So there's a 1 at the bottom. You can turn anything into a fraction by simply putting it over 1. Okay? So don't freak out if I just give you a whole number. We good? Alright, last thing. We're going to talk about inverse trig functions. Okay? Let's talk about inverse trig function. So, here's the situation. It says use a trigonometric function to find the measure of theta. Round to the nearest degree if necessary. So, use a trigonometric function to find the measure of theta. Round to the nearest degree if necessary. So, I give you this right triangle. I tell you this is 11, this is 26, and then I tell you that this is theta. Okay? So, it's a right triangle where, according to where theta is, what does 26 represent? If this is theta, 26 represents what? Opposite, and then the 11 represents the what? Adjacent. We good so far? Okay. What's the difference here? What am I asking for? I want the degree of theta. So this is totally different. I don't want side lengths anymore. Now I'm talking about inside the triangle. I want the measure of theta. Everybody needs to understand we want the measure of theta, and more specifically, in degrees. I want it in degrees, okay? So, how do I find that? Well, with everything, guys, I need to find a relationship. Is there a relationship with the information I was given? So let's find our relationship. So my problem is this. Most people will get this and be like, oh, I need to find the hypotenuse automatically. I gotta know how long the hypotenuse is. Why? You're just adding more work to yourself. Because look at what I was given. Here's theta. I'm given the what? Opposite and the adjacent. So according to SOHCAHTOA, if I know opposite and adjacent, which relationship am I going to use? The tangent. Does everybody understand that? There's no need to know the hypotenuse. If you want to, be my guest, fine, and you can use sine and cosine, but I don't have to. I have a relationship that involves the opposite and the adjacent. So does everybody agree to this? That whatever theta is, that my relationship, tangent of theta, is going to be my opposite, which is 26 over 11. Does everybody agree to that statement? That tangent of theta is equal to 26 over 11. Right? Does everybody see what I did? I found my relationship. There is a relationship with those side lengths and that angle. Agreed? Now, I want what? Theta. I want theta. So here's the thing. Theta represents my angle, correct? And I want this alone. So what's bothering me? The tangent. So these are functions. These are trig functions. They are not multiplying. Okay? It's actually taking tangent of something. So the way you get rid of sine, cosine, or tangent, the way you get rid of functions is not by simply dividing. What you're going to do is you're going to take what we call the inverse function. Okay? So here's what I want to do. I want to take the inverse function of tangent. So if I take an inverse function of another function, what happens? They cancel. It's just like if I want to multiply, I divide. If I want to add, I subtract. So if I want to take a tangent, the way I get rid of it is take the inverse tangent. But guys, this is an equation. So whatever I do to one side, I have to do to the other. Y'all did this in physics, no? Right? So what's going to happen over here? They're going to cancel. So does everybody agree that theta is equal to the inverse tangent of 26 over 11? Agreed? So guess what? I don't understand that. If you tell me, hey, what's the measurement of that angle? And I say, oh, it's the inverse tangent of 26 over 11. That makes no sense to me. Besides, I want it in what? Degrees. So let's bring out our handy-dandy calculators. Okay? Do me a favor. Clear it. 2nd plus 712. Clear your calculator. And I want to do some trig on this thing. Does everybody know where your trig buttons are? Yeah. No, I don't. Right up the middle. So right above 7, 8, 9, there's a comma and 2 parentheses. Right above those, you see it says sine, cosine, tangent. So on your last homework assignment, that's what you'd used. If I asked you for the cosine of 10 degrees, you just did cosine of 10. Bam. Right? So does anybody know where my inverse trig functions are? They're the second of these. Okay? They're the second of these. So now, if I do second sine, that's actually inverse sine, right? If I do second cosine, that's actually inverse cosine. And if I do second tangent, that's actually inverse tangent. Got it? Now, here's the problem. Here's the problem. Pay very close attention. By default, guys, by default, your calculator is in radians. And I need it in what? Degrees. So be very, very careful. Because if I do it in radians, I will get an answer. It just won't be the answer that I want. Does everybody understand that? So you go to mode right here next to the second button. Just press mode. And you're going to go down to where it says radians in degrees. And you highlight degrees and press enter. Now my calculator is in degrees. So now I can quit second mode, and I go back to my blank screen, okay, and do what I need to do. So I need to do what? The inverse tangent, and then I can do a fraction of, what was it? 26 over 11. Okay? So the inverse tangent of 26 over 11 is approximately 67.067. But I notice what I told you. I told you round to the nearest degree. So I got theta is approximately 67 point, what was it again? 0. Right? Yeah. I got this as my answer, but I said to round to the nearest degree, so therefore theta is equal to what? 67 degrees. So that's my final answer. So did you see how I did this problem? What's the first thing I did? I have to find my relationship first. Is it always going to be tangent? No. Okay. So figure out your relationship first. Based on what, though? Two things. Based on the given information and theta, wherever theta is, right? Because that's what determines your relationship. Based on the given information and theta. Now, students always ask me, yeah, but what if could I use secant, cosecant, and cotangent? Sure, you can. But notice your calculator does not have what? Doesn't have those. But does that mean I can't do it? How would I do that? How would I do secant, cosine, and cotangent? Remember, they're just what of each other? Reciprocals. So like if I wanted to do, let's say the cosecant. Cosecant is the inverse of what? Sine. So all I have to do is this. I do 1 over sine of blah, blah, blah. Does that make sense? So if I asked you for cosecant of 23 degrees, so I would do 1 over sine of 23 degrees. Does that make sense? Okay? Because that's what a reciprocal is. Reciprocal is you take it, put it over 1, and you flip it. Right? So it would just be 1 over. So, but I would say, don't worry about that. Stick to SOHCAHTOA. Stick to these. Okay? Stick to those. So finally, see if y'all can figure this one out. Just try the first one. Try the first one. The 14 and the 16. Alright, so I have that right triangle. Okay? Guys, based on theta, here's theta. What does the 14 represent? It is my opposite. And what does the 16 represent? Everybody agree with that? Okay, so then what's my relationship? Why is it sine? Sine is opposite and hypotenuse. So does everybody agree that sine of theta is equal to what? Opposite over hypotenuse. So it would be 14 over 16. Agreed? So you can simplify it. It doesn't matter because isn't the calculator going to do the work anyway, right? So it'll give you the same answer. It doesn't matter to me. Okay? So sine, does everybody agree with this, at least this initial equation, right? That sine of theta is equal to 14 over 16. Agreed? Now how do I get theta? Inverse sine. I have to use inverse sine. So basically what I'm doing is the inverse sine of both sides. So that these will cancel. So theta is equal to the inverse sine of 14 over 16. So in your calculator, do the inverse sine of 14 over 16. And I want, so basically theta is equal to what? 61.04. So then that's 61 degrees. Got it? So let's say I made it real hard and said, okay, now find me the other angle. Guys, 90, 61, subtract from 180, right? You know they all have to add up to 180, right? So could I use another trig function? Sure, but you don't have to. Common sense kicks in on that one. All right, the next one, it looks really hard because now I have a what? I have an x, okay? Now I have an x. So you think I'm going to change what I'm going to do? Depends, maybe. We'll see. So here's my theta. What does the 5 represent? Adjacent. What does the x represent? So this is adjacent, and this is my hypotenuse. Agreed? Okay. So, oh well, this doesn't apply. Well, yeah, it does. So sine, or I'm sorry, what is my function? Cosine. So it would be cosine theta is equal to 5 over x. I actually can't do this for you. I tried to show you something, but I can't do it. Let's just make this 12. So then it would be 5 over what? 12. So I want to show you something, but in a second. I couldn't, because I can't give you two things you don't know, right? I can't give you two things you don't know. So let's just figure this one out. So inverse cosine of 5 over 12 is what? So theta is equal to the inverse cosine of 5 over 12. So theta is equal to, so we'll just say 65 degrees of 65 degrees. Okay? Can everybody go with that one? Yes. No, I gave it to you. I gave it to you. So let me kind of sidetrack, okay? So let me talk to you for a second. So say I gave you the same equation. Pretend that's a right angle. I say to you this is 5, and then let's go back to me making that x, okay? But the thing is, I can't tell you that I can't say you don't know that and you don't know this, because that's too much. You can't have two unknowns. But say I gave you this, okay? Say I gave you that, and now I say find x, okay? Now, can I use Pythagorean theorem? No. Why not? Because I don't know this side either. And for Pythagorean theorem, you need to at least know two sides. I don't care which two sides, but you have to have at least two sides. Agreed? So, I can just say, hey, this is my theta, and use the same relationship. But my relationship would look like this. Cosine of 65, since I know what theta is equal to 5 over x. Agreed? Now, how would I find x then? Good. So here's what I would do. So x is over here in my denominator. I don't like it there. I need it out from the bottom. So couldn't I just multiply both sides by x? Right? What's actually going to happen over here? So does everybody agree that x times cosine of 65 is equal to 5? Now solve for x. What would I do? What are they doing? So then to get it by itself, I need to what? So x is equal to 5 divided by cosine of 65. Right? Now put that in your calculator. What's 5 divided by cosine of 65? So x is equal to what? 0.8 degrees? No. Because I'm not talking about I'm not talking about an angle, I'm talking about a what? Do you see how it was actually pretty close to 12, right? Pretty close to 12. So I can do both things. I can say find theta, find me the angle, or if you know the angle, find me a side length, okay? So these relationships work both ways, okay? So you are going to have questions that look sometimes like this. You still start off with the same thing. Find me the relationship. There is a relationship with the given information and with your angle, okay? Any questions? Okay, we'll work on these because I feel like this might have confused you a little bit. But we'll work on those